important, but you have programmers to do it for you sometimes if you're not a programmer. And you also need other softwares. So if you're not a programmer, we have to create art and sound effects. So you got art assets and SFX through things like Asset Sprite or Reaper. Technically, you don't need an IDE. You just need to be able to modify the scripts. So if you want to use a text editor like Notepad and be insane, I guess you can. Moving on. See, chapter slides go fast. Engine choice. Let's talk about engines. There are a lot of game engines. In fact, one of the projects is developing a game engine this semester. For this workshop, we're going to be using Unity. Now, if you're more comfortable in Unreal, Godot, Pygame, Roblox Studio, whatever engine you want to use, you are free to use it for the game jam or whatever. It's just that Unity is going to be used for most of your projects this semester, the long-term ones, and it's also personal preference. So moving on to the next slide. This is why we chose Unity, right? We got plenty of resources. Unity has a whole big community of resources. They also have really nice documentation. If you ever look at the documentation page, easy to navigate. Again, it's personal preference. I like Unity, and I'm hosting, so. But again, you can also just use whatever you want, you know? So, Roblox Studio, great for beginners. Godot, great for beginners. Unity, great for beginners. Unreal, not great for beginners. Moving on. So, let's go over to our demo slides so that we can actually see Unity Engine's UI in action. All right, so this is the Unity engine. Now, it looks kind of daunting at first, but honestly, it's quite simple. Down here, you have the folders for your projects. Now, this is assuming you've opened up your project. Have you all gotten the projects to open? Is anyone having problems opening up their projects? Okay. Just raise your hand if you have any questions and let me know, and if there's something that's wrong, I might send an officer over to help you. Over here, again, the folders, right? So this is how you navigate your project. Can you click the assets folder for me? Thank you. I believe if you open up your project, this is the folder your default be in, because this is like what Unity likes. Here we have a folder for art, prefabs, scenes, scripts, and settings. We'll go over a bunch of these later on. But for now, why don't we just hop into scenes, for instance. So this is the scenes folder. This is like the most probably not descriptive folder of all the folders in Unity. This is just basically your levels. This is how you construct a scene or a level or however it's designed. And so these little things are Unity scene files. So if you want to just click on one of those scenes, sample scene for instance, this is our template game that we have on Discord. If you downloaded the Discord template, you should have this too. Yeah, so over here, we have the objects in the scene. Now we've already built the scene, so there's a lot of objects here. But if you make a new scene, you'll have an empty objects. It'll be really easy to add objects, and I'll show you how to do that in a second. Click any of those objects for me. Thank you. These are the components of the object. I forgot the term for a second. This looks really confusing, but really, every drop-down menu is one component. So like, the box collider is a component on an object. And I'll talk about box colliders a little more later on. Okay, let's hop back over to the slides, I think, because that makes sense for the overall engine. So moving on, our next chapter is player input. I probably should have demoed making something in the Unity, and I will do that in a second. So, player input is usually the human interaction with the game. How is your player playing the game, moving their character or controlling the game or affecting the game world, right? So that oftentimes this is controls for a player character. And these commonly use what's called a rigid body component. I will show you what that is when we go back to the Unity. Yeah, and the rigid body component adds physics to your thing. So you don't have to worry about coding physics from the ground up. A lot of Unity has some stuff in it already. And you can also use the input action package, which is a newer package, and I believe in the 6,000 version of Unity that you installed, hopefully. It's like makes player controls much simpler than it used to be. So moving on, let's head back to the demo. All right, so we've opened up a new scene this time. So if you guys want to make a new scene, it's super simple. You just have to right-click down in this body here, and one of these says new scene. Create something. It's in here somewhere, I promise. There you go. So we're going to follow that train of clicking, you can get to a new scene. So in our new scene, oh, we've actually created a new scene. Awesome. Let's create some objects. So let's just make some 2D shapes. Sure, you can add sprites later, but for now, if you want to make sure your game functions, it's great to just work with shapes. Unity has a whole bunch of shapes and sprites. You have triangles, squares, circles. I'm not going to read the whole list. But yeah, you have all sorts of shapes and sizes that you could work with. So let's just click any shape really quick. So here you can see two displays. One of these is basically what the game's going to look like, and one of them is more of like your dev screen, okay? So this camera icon on the dev screen, which isn't in the game screen, shows the camera like sizing and positioning for the game screen. Okay? So has everyone created an object in their scene? We all good with that? Okay, I hope we are. So you can make the object all sorts of shapes. So if you want to like click on the square really quick, you can resize it however you want with the little dots and stuff. You can also move it and scale it over here. So you know, you can do it with numbers or you can do it manually, whatever your choice is. So let's go ahead and turn this into a player. So to do that, we just have to add components to our object. So we're going to add our, which one do we want to do first? Rigid body?
Yeah, you mentioned that.
Yeah, let's add a rigid body component. So because we're in a 2D game, we're going to be using the rigid body 2D specifically. Go ahead and throw that one in and drop down the menu. Awesome. Okay, cool. Yeah, so this is a rigid body component. Let's go by and take a look at what all these mean. Body type dynamic, kind of just like it reactive. The material, we can add a material to this later. It's simulated, it's auto mass. We don't worry about these right now. So here's like some Unity engine physics stuff. Like I said, rigid bodies include some physics. So we have a gravity scale. We have mass. Who here has taken physics? You probably know what these are. It's just like equations. The damping, don't know what they do. But honestly, just play around with it, to be honest. Yeah, and then you can also freeze its position if you don't want it to move. But because we want this to be a player, we don't want to do that. So let's go ahead and just run it for now to show off that adding the rigid body adding the rigid body adds physics. So when it finally loads, it should fall to the void. Like I said. That's magic, guys.
That's crazy. I did it.
You might want to, reset instead of. So yeah, you have up here, you have like kind of blocking things, but that's the play button, the pause button, and when it plays, this turns into a stop button. So like you can pause during mid-play test just to see, okay, is this functioning how I want it to? And you can also have to like stop to make it go back. So if we wanted to, we could make it fall faster by editing the gravity scale. 10. Awesome. Let's have it run again. And it falls faster. Simple enough, right? And that's the basics of a rigid body. You know, that's all you need. Let's go ahead and add a player controller to this one. So, in your template, we should have given you a script. And it's just called player controller script. So we add a script component, okay? And this script component runs our file that we called player controller. And if we open the script, are we going too fast? I can go a little slower.
I didn't say anything.
I'll go a little slow for you, don't worry. We got time.
Where do I put the script?
Is our script here?
Yes.
Okay, cool. Where do you put the script? Let's go back to Unity. So let's just you add a new component, right? So add component. You're gonna want to search script or player component, whichever. FizzBuzz. There you go. If you search anything in this thing, it's gonna give you ask you if you want to make a new script called that, basically. So you can hit new script, and you can make a new script called whatever you want it to be. So yeah, let's go ahead and hopefully you've got your script running. And let's hop over to our script.
Hold on. Where do you find the script in the actual project for the template?
Alvin, where do you find the script in the actual project for the template?
So if you create a script in the inspector itself by creating a component, it'll be in the assets folder. But I like putting them all into one folder called scripts for organization.
Yeah, organization's nice. You know, technically you don't need most of these folders, but it's nice to have organization. So let's go ahead and open up our code again. Let's start coding a player controller. So I'll let Alvin start running it, and I'll just talk about what he's making at the time. So we get the rigid body. Well, for now we're making a variable that's a rigid body type, because we're currently working off of the Unity API, Unity engine. How many of us here are actually coders? Just curiously. Okay, that's good. Because this is very comp sci-y. This is C# language, if anyone's worked in that. I know school here doesn't teach C# really, but it'll look very similar to like Java, to be honest. So yeah, we use the Unity engine API, which has all sorts of things we need, okay? Rigid body is one of those things that we need. It's a type, and if you remember correctly, also a component we added to our object. We also gonna just give it some values, so like a player speed value and a gravity scale value, and just the gravity value in general, which happens to be -9.8, because you know, physics. Technically, you can do whatever you want it to be. Okay, and then moving on. Uh-oh, did we freeze? Well, that's a gosh darn problem.
I just want to say, I'm doing Unity on Mac for the first time for, like, because I've done a little bit of Unity. You do need a code editor for it, and like, I'm guessing you're using Visual Studio, right?
Yes.
We are using Visual Studio. Technically, you don't.
Technically, you don't need to use Visual Studio, but like a lot of people recommend using Visual Studio.
Well, a lot of people recommend using IDE, period.
Yeah.
I wouldn't recommend coding on a notepad. Go ahead.
Yeah. Kind of to add on to that, I think like the most recent stuff on Unity, like I think they're pushing to require Visual Studio. So if you guys are like, if you guys are still like downloading right now and it's pushing you to do that, there are going to be, I think, extra packages for that. So don't be afraid when it's just like, oh yeah, we're also downloading Visual Studio as well. So
Yeah.
it's kind of a push.
Visual Studio is honestly great for Unity. It works very well, and honestly, a great IDE in general for your classes, to be honest. But yes, you could write your scripts in Notepad. You can write your scripts in whatever text editor you want, but it works better this way. Okay. How's things coming along on stream ends? Do we have?
Good.
Can we switch to the other scene that has the the Unity that's hopefully not frozen? Unfortunately, this makes things a little bit more not streamlined. Okay, so now we're on a different Unity, but hopefully we're caught up close to. So again, Unity has a built-in text editor, so you actually could edit your code here. I wouldn't recommend it. It's very easy to make typos. It's very easy to blow up your code this way, but you could. So, oh, I know what the problem. We don't have a source for the script. Do one of you guys want to switch places with me really quick while I add that
Yep.
source?
Yeah, really good. While they're working on the tech checks, if you guys need any help with catching up with third parties, just feel free to wave one of us over and we'll help out.
This is
He's yelling at me.
Is that capture?
Also throw in, like, what's
I
really
could try
convenient
using
about all
capture
of this
with
is
that.
Unity, when you make an account with Unity, you go to the website / like the Learning Hub, which is all attached to the like the Unity
Yeah,
server
okay.
when you first
Okay,
open
cool.
it. They have a ton of free tutorials, and they keep track of your progress.
Yeah.
You can actually make a
That's the
resume
easier
from it,
version.
and like they have a bunch of job listings associated with it as well. But basically, you can learn all of these different blocks, and even like follow along with the tutorial where they'll give you a bunch of assets and show you how to like import and all that, all of it from the Unity website. I just found it really useful because I don't know, this was like really intimidating for me like 2 months ago when I didn't know anything about it, and I still don't. But I don't know.
Yes,
Super
I love it.
helpful.
Yeah, that's one of the reasons why we chose Unity. Unity has great resources, lots of tutorial resources, and lots of like, oh, here's everything you need to do to make your code function. So, we're back. Let's go ahead and grab our rigid body component. So remember earlier I said we declared a variable of rigid body type. Well, now we have to get that component. So like basically what this is doing, so get component rigid body. What this does is it captures the component that we threw onto that object over here in Unity, right? So this will grab whatever that component's details are. So then moving on, we're gonna use a fixed update instead of a regular update. This is like, has to do with like timing and stuff. Everything that happens in the start function evidently happens when you start the program. So when we start our program, we get our rigid body component. See, isn't code so simple? And then in the fixed update, when your game is running, there was just an update happening. And fixed update is like a more rigid version of it. And so every time we have an update, we're going to check for a key. Now, key code A. This means we're looking for specifically the A key press. Get the typing. Awesome. We now have a linear velocity. So, our rigid body has physics to it. Like I said, we create movement, we simulate movement by adding velocity to that physics. So, when we press the A key, we add a amount of linear velocity that points left. And as you can as you can see, we have to like do this for every key we want to click, right? So D does it to the right, W will do it upwards, and S does it downwards. And now you have your basic WADS. Does that sound simple enough, everyone? Any questions? Awesome. So moving on then, we can showcase this on our engine. Now, if we ran this right now, he'd still fall to the void infinitely. It might take a second because I have to load up the scripts now. Every time. He still falls to the void instantly, but I assure you he is getting our controls. So let's go ahead and stop that. So how can we test that he's actually getting controls? Well, let's just turn this from a platformer to a top-down. Since we have no settings right now, let's go ahead and change the gravity scale to 0. Now we should have no gravity. So if we run play, he doesn't fall to the void. Man, life without gravity. And now we can see that when we play with our WADS, he moves as we coded it. So we're adding a bunch of velocity to this rigid body whenever we click those keys. And we have our scripts to allow changing for the speeds, right? So we added, remember if we created at the very beginning, at the top of the script, we added a player speed. And then when we call our velocity changing. We're changing it based off of player speed values. This helps us keep control over the speed if you want to make it faster. Now, here's the thing about Unity. If you change a value while your game is running, it does not save. So if we change this to like 20 billion or whatever, 20, sure, and we hit stop, it goes back to 2. Why Unity does this? Testing purposes. You can test like this. But you always have to remember that if you make changes while it's running, you're going to have to change it when you stop running it. So if we did want the 20 speed, we have to change it here. And I think that's it for player controller. So let's move back to the slides. Question, yes?
Yeah, I have a quick question. If you go back to the Unity scene.
Back to the Unity scene, Shaheel, I'm sorry.
There is a box, right, for player speed. Could you explain how you get that box as well?
Yeah, so let's hop back over to the script. Sorry. Let's see. Oh, really? You don't serialize field anymore? Is that different than 6,000? Okay. Before 6,000, we had to do like serialized field or whatever. Now we set it to public. If it says public, it'll just show up over there. So you notice that this gravity value, this doesn't show up over there. It's a constant anyways, but it doesn't show up over there because it's private. But because that's public, I mean, we could even try it. Let's go ahead and set it to private, set gravity scale to private really quick. And save it, and then back over. It's gotta hold on load. You'll notice that we lost our gravity scale because we set it to private. So yeah, that's how you get it down here. It's public versus private. Okay. So that's our player controller. Let's keep moving on. Our next chapter is about collisions. So we have a player controller, but like right now it's just gonna pass through everything. In fact, there's nothing in the world with him. So let's start giving things a physical presence in our game world, basically. Collider components allow things to, as the name implies, collide, but it also gives you the ability to add material. So let's move on to a demo. Now moving back over to Unity. So let's go ahead and create a platform for our character so he doesn't fall into the void. So again, we can move things like this. So we can also use transform, same as the player character. And we can make him very long. So now we have a very long floor, okay? Let's go ahead and add our 2D collider component. Sorry. This gives us a physical body. Now, let's talk about the component, if we can select it again really quick. You can edit the shape of the collider with this thingy. It might be really, really hard to see, but there is like this green dot thing and the green lines. That's the shape of the collider. So technically, the collider doesn't have to be the shape of the thing it is. You also have its material, okay? We can add material to it later. You have is trigger. This is basically if something collides, it shouts, hey, you triggered something. Oh, are we changing its color? Yeah, let's change its color so it's not the same as the player. That makes things look nicer. And those are like the main important ones you need to like make things function. You can look into what these do on the documentation. Yeah, that's probably good for that. Let's move on to. We also have to give things a name simply for the sake of it's not square and square. It makes things much easier to navigate in your scene. So let's add a component to our player, because right now, if we played it, the player doesn't have a physical collider. So even though the platform does, if we just move the player down, he's gonna go right through. So let's add a collider to the player. Both things that collide need to have colliders, so that they both have a physical presence. And now, simply enough, we could just play it. So now we collide straight with the thing and we can't move past it. Now, again, like I said with the platform, we could change the shape of the collider. We can make the collider much taller than the actual shape is. And what's going to happen now is, if we play it, we're going to collide at this level. See? Collider doesn't have to be the same as a sprite, which our sprite is just a square. Okay, so now we have colliders. Do you want to turn on gravity really quick?
Yep.
And play it with gravity. Let's talk about material. You might find that your platform feels a little bit slippery, because right now there's no materials, so things almost have ice-like physics. Everything slips and slides everywhere. There's not enough friction. So to fix this, we add a material. So we're going to go in here and create our material. Alvin really doesn't navigate this. This would take me an extra 5 minutes if I was doing that. We have these 4 values. I'm going to go over friction. And honestly, that's the only one you really need to know. But like, you can have fun with bouncing this too if you wanted to. So to make things slide less, we just give them a friction value. This is, again, physics. So then when we have our material that we just created in this section down here, we just give it to the materials category here. You could click it and then select it, or you can just click and drag. Both of those work as options. I love the name player slower downer. This is a very true statement. So we give it some more speed. You know, he slides a little less now. We can increase the friction massively. So let's make this 20. Yeah, material box collider. So the reason why it's rolling is because there's so much friction now that it can't just slide around. It's like if I tried to like slide this water bottle with this very frictiony rubber thing, it's just gonna fall to the ground. I'm sorry. But that is how we add friction to make it not slide. Now you could also fix the rotation. Freeze rotation. Now we no longer flip and flop all over the place. And we have no slipping. And that's how you make not ice levels. All right, let's move back over to the slides, and let me pick these up from the ground. Question. Hi.
I didn't catch that. How do you make that?
Sure, let's hop back over. I can. No worries, no worries. We've got time. I do kind of like run a little bit fast sometimes. So, I believe right now it will flip and fly. Yeah. So, right now it has rotation to it, but we don't want it to rotate. So if we come down to the rigid body component, we have a constraint called freezing rotation. So if we just click that, we now no longer rotate because it can't rotate on the z-axis anymore. Yeah? Awesome. Now we can hop back to the slides, unless there's any other questions. Cool. Next chapter, triggers and non-triggers. So I mentioned this very briefly with our collider components, but you can make a collider a trigger. And basically what that means is, if something collides with it, it screams, hey, I've got a collision, I've got a trigger, okay? This also tends to make things not physical anymore. Just a heads up. So you can also give these objects tags or layer masks. one, they're great for organization. Two, it also gives you a way to define what the trigger is. So we're doing another demo. Let's hop back over. All right, so let's create a new component. We're gonna make a trigger now. And let's, for making things a little more clear, we're gonna make a circle. We're gonna just make it however we want to shape it. And we're gonna put it where we want to make a trigger. We're gonna add our collider. Now, you'll notice there's different shapes of colliders in that collider section. I could give a circle a square collider. Again, the collider is not tied with the sprites. But for sake of making things clear, I'm gonna make things a circle collider. By I mean Alvin. So let's go ahead and take a look at our circles collider. This is trigger button right here. That is how we define it as a trigger versus a physical entity. And now we've made a trigger. It's quite simple. So now, when we run our script, we no longer collide with it, and every time we pass through it, it's going to be like, okay, there's a trigger happening, but I don't know what this trigger is. And that's where tags and layer masks are going to come in. So let's go ahead, and you might have to close your running so it saves the settings. We're going to add a tag. Now, in your downloaded template, we had coins on the scene. You might be able to pull up the scene too. These are quite, your average coin settings. So just, you collect it, you collect the coin. So we're going to do that again for our scene, just for the sake of it. We add a tag here, and we have a named coin, but we can also just show you how to make one. Just hit the add button, and now you have a new coin tag. So once you create it, you want to give the tag to the coins. Now we have new coins. But that still doesn't really give us anything. Now we know what the collision is. We know that if we collide with this collider, we're going to say, hey, I've got a trigger for new coin. What do we do with that? Well, we can make some things to do with it. So let's go ahead and add a script for this. We're going to name our script coin thing, because you can name it whatever you want, really. Awesome. So here's our script for coin thing. Looks very similar to the beginning of our other script. So we're going to have to make it different, basically, by removing everything. Most things don't need all of the start frame and fixed update frames that you have on the player. Some things can just simply be an on-trigger function. So on-trigger enter 2D collider collision. This is a lot of words to say, basically, hey, when we collide our collider component with this thing, we enter the collider. We're going to make this collision thing. So we're going to get the game object for this collision. So when we collide, right, we get, okay, here's your collision. This is what the details are. If we make sure that the collider is the player, because we added a player tag, one, you can log it to see. This is how you debug things. It's very helpful to see what's going on. Debug.log simply just throws a little text into the bottom of Unity that'll say, hey, this is what you told me to say. Yeah, and then you're going to destroy this game object. Because we don't really do anything with our coins, but we don't want our coins to stay after we pick it up. And so now this is basically our collision functions. Does anyone have any questions on this on the code? I see someone taking a picture, and I see a question. So let's hop back over to the code real quick. What's the question?
So this is a script on the coin, right?
This is a script for the coin thing.
So basically, it's like the coin saying that when the player flies with me, I'm gonna do this stuff.
Yeah. When we enter the collider of the coin's going to pass this collision into this function. We're going to be like, hey, this is the details.
we're going to see which game object that collision was, which game object was part of that collision. Yeah. Which game was part of that collision, and we want to make sure, by comparing the tag, that it was the player tag. And then we do our function.
So my question is, could you do it the other way? So could you have the player seeing the coin fly to it? Does that make sense?
You could, but you wouldn't be able to destroy this .game object.
I see.
This is a very simple way to just destroy it. Now, if you want to have like some code somewhere to count the number of coins or do something with your coins, maybe your player gets a power up when he picks up a coin. Well, you could. Yeah. You want to explain that one?
Oh yeah, that would kill the thing that touched it.
Okay, yeah. So, the collision. You can put it back really quick. The collision. This is one way to destroy the thing that touched it. Is this collision? So let's say this is in the player script all of a sudden, and we say compare tag coin. So in the player script it says, okay, that thing I just collided into, get rid of it. We don't want it anymore. That's one way to do it. Many ways to skin a cat. Okay. Any other questions? All right, let's showcase it. All this talking has me so thirsty. I should have grabbed more water before I left. So now, if we walk straight into that coin, it destroys itself. Yay, we destroyed a coin. But that's how you do a trigger, right? You can do all sorts of things with triggers. You can make checkpoints, you can make a death barrier, you can do whatever you want. This is just an example as a coin. All right, so let's head back to the PowerPoint. Our next chapter is asset usage. So, wonderful assets. I see our asset designers over there.
I would just want to say, whoever made this art, it makes me really emotional. It makes me cry.
These are quite beautiful assets. So, this is how you give your game personality. Of course, you could do everything with basic shapes in Unity, but generally that's used more or less for prototyping your game. Make sure that you have code that functions. When you want to make it look pretty, you want to make it like the characters you want it to be, the environment you want it to be, use assets for it, instead of just doing everything in the Unity engine. Wait, I didn't back to the demo slides. Sprites, yes, sprites. So, here's a sprite renderer. This came with our object. We didn't add this, but you could also technically add it, I believe, through add components and stuff. Right now, it's the square sprite. But if we want a different sprite, we can just throw it in. So we have our player, I'm gonna come over here so I can show you the folders. In our assets folder, we navigate to our art folder, navigate to our sprites folder, find our player. Okay, this is the organization that we decided in, but you know it makes sense, right? Art is an asset, a sprite is an art, and a player is a sprite. Well, this player is a sprite. So we just take this little drawing, and we just chuck it in, and now we have a sprite on our player. And we could do the same for a coin, right? We have our coin sprites, and under objectives, I think. Yeah, we have our coin sprite. Simply just throw it in, and now our coin looks like a coin. A little small, but it looks like a coin. And yeah, that's a sprite. The hardest part about sprites is honestly drawing, in my opinion, but I can't draw, so. Again, it'll look the same as always does, but we don't need to showcase it since it'll just take time to load the thing. But that's our sprite loader. So hop back over to the slides. NPCs. So, instead of a player-controlled movement, we've got logic-controlled movements. That logic can really be whatever it wants, including Marin Karin for meet Suru. Useless. So moving on. Let's make an NPC and let's make it move. So we're going to add an entity, an object in here that isn't the player, right? We had the coin, we had the floor, but let's add something else that moves. So we're going to add it to the object. And it's our bad guy. And we just go through a whole lot of the same things. So, we have a rigid body now. We give it some physics. We have a collider to make it physical. We have a sprite, so we can just throw that sprite in. Our lovely enemy sprite. And now, we just have to, code it. So let's go ahead and add our code for our NPC here. So like always, we make our script, and we load it up on Visual Studio. Unfortunately, it does take some time to load IDEs. Wow, it's taking a real long time to load the IDE. That or he froze. Awesome. So now we're on the script for our NPC. So, like the player, we're going to want to get the rigid body component, because this is a very important component to have. We're also going to add
I got a
speed.
question.
Oh yeah, go for it.
What coding languages are you using in Visual Studio?
Unity uses C#. It's not a Visual Studio preference, it is the Unity engine preference. Unity specifically uses a C# language for all of its scripts.
Right. I only know how to code in Python and Java.
Yeah, so that's one of the great things about Unity. There's a lot of documentation that help you, right? I think personally that C# looks a lot like Java, right? You have your public versus private, you declare a class, and this is how you just name the class. You have public private, type, which happens to be rigid body type, or float type, and you just name it, right? So all of that looks very kind of similar to Java, at least for variables here. And functions also look kind of similar. You have a void function. We don't need a return value, but you could make one with a return value. You name it, any parameters it might need, a body, and just some details about it. And since this is just a language versus a Unity specific thing, you can also find documentation and help for how to code in C# on other web pages. I think W3 Schools has a C# page, and W3 Schools is honestly a great web page to learn code. Also helps me get through my coding classes, so. But yeah, does that sound good? It's just, sometimes it takes a matter of just stepping in and learning the new language. But luckily, a lot of coding languages share a very similar logic to it. And this one has a quite similar logic to Java. Okay, so let's talk about all this code that Alvin's been writing while I've been talking. So, again, we have enemy speed, and we have direction. Remember, we have it public, so that way we can change it whenever we need to in the Unity engine. On start, since we have a rigid body, we're going to need to get that rigid body component. We're also going to have it go in a random direction. So, when it spawns, it's gonna decide, okay, do I want to go left or right? And we do that by choosing negative or positive. And this is just some math and random functions I believe you can get in normal C#. I think. That or it's in Unity. But yeah, so then what are we gonna do with those directions? Well, we want it to move in that direction. It's when it spawns, it shows, okay, I'm gonna move left or I'm gonna move right. So we're just gonna give it some velocity. Again, we have a rigid body component, so we just add some velocity physics left or right for it. So instead of getting a key press like we do for the player, we want logic to dictate it. And our logic is randomness. So when it randomly decides where it will go, it's gonna just move in that direction, right? Now, we could make it like a Goomba, and it just kind of walks and walks and walks, and maybe falls into a pit. Or we can figure out when we run it to turn it around. Here, we check, okay, if we hit a wall, meaning our velocity is 0, because you can't move past the wall, we're going to turn around the other direction. And that's what that code does. So, if we go ahead and run our game, he moves. And he moves against us because he doesn't do anything when he touches us, but he moves. So we can showcase it turning around by just giving it a wall somewhere. So let's create our wall. We need a collider on that wall. We're gonna go straight through that wall. There we go. We collided with the wall. He hit 0 on his velocity because he can't move past us, past the wall. So he goes in the other direction. And that's our logic-controlled movement. Great. And then moving on. Oh, yeah, we have to just add the thing to the wall now. Keep it. Moving on. And now we have what a prefab is. So, prefab, what does that really mean? Well, the easiest way to put it is that it's Unity copy and paste. I don't know why we need a complex word for that. This is a great way to duplicate objects in your game environment, right? So, we have one enemy, but if I want to make more than one, I don't have to do all those steps. And I don't have to like, oh, here's a block, here's an object, here's its sprite, here's its collider, here's its script. There's easier ways to do it, and that's with the prefab. So, let's go ahead and showcase the prefabs. All right, back in the Unity, we do have in our folder, if you remember, a prefabs folder. And all we have to do is just make a prefab from one of our objects. So let's find our bad guy really quick. If we want to make him a prefab, because we want to duplicate him multiple times, I actually forgot where the button is. There's a button for it somewhere. Duplicate is one way to do it, is you just duplicate the object. Well, that's not necessarily in the prefab section, because if we want to add him in a different scenes, well, you could copy paste him to a different scene. But if you want to just spawn a bunch of them, there's prefabs for that. But honestly, it's just copy paste. So, yeah, we can just create a prefab. So in our prefab folder, we have an object for bad guy. And this basically means that if we wanted to, we can just get him when we're on a different scene, or we can even use scripts to get him. Do we have a script to get him? We don't have a script to get him, but it's one way to get spawn things, basically. But yeah, that's a prefab. It's a super complicated word to just say, I'm gonna copy paste him a bunch. And that's our template game. So that's it. Thank you all so much for listening to me rambling on. And please give a big round of applause to Alvin and Shaheel over here who have helped me through all of this. Any questions? I heard someone. No? Okay. How much time do we have?
Well, we have until 8 p.m., but if, yeah, we have a lot of time.
We have a lot of time. We have over an hour. Well, actually, we have exactly an hour. Question?
How much does that game cost?
I mean, truthfully, it could be however much you want it to cost. It's whether or not it sells.
It's a free, but it's subscription based.
It's subscription based.
Should we worry about copyright?
No, the art assets were done by ours truly over here.
Will LeBron James be in Unity?
You could technically, hypothetically, make a sprite of LeBron James and throw him into the sprite renderer of an object, and you have LeBron James in
Yeah!
Throw an image.
Or you can just throw an image. Okay, anything else? Let's add some, okay. Okay, then I'm gonna open up the floor for you guys to, one, mingle, because Game Jam, this is a great time. We have a bunch of people all lined up here to find a Game Jam group. And they'll let you just kind of play around with the Unity engine, play around with the template, play around with the new scene you just created, create even more scenes, try new code, you know? And yeah, we're around to help for a little bit. Question? Yes, you can, for as long as I'm here at least. All right, have fun. Thank you for attending the workshop.
Thank you guys.
Stop the recording.